Electricity. It makes our world light up, move, and connect. But what is it? How does it work? And how can we use it? Let's dive in and find out together. This series is designed to work along the SparkBlocks Intro to Circuit Kit. It'll teach you the fundamentals of electric circuits so you can power your world. By the end of this video series, you'll be able to design and build circuit diagrams, diagnose problems with circuits, and build circuits for your own projects. To understand electricity, we need to get small. Really, really small. Electricity starts with tiny particles called electrons. They're in nearly every atom, in everything around you. You can't see them, but you can see their impact. When electrons move from one place to the other, it creates an electric current. That current is electricity. Electrons need the right material to move through. Some materials are easier than others. They allow electrons to move from one end to the other. Materials that are easy for the electrons to flow create good pathways called conductors. Other materials can be nearly impossible to flow through. They stop electrons in their path and force them to try a different direction. Those materials are called insulators. To build electrical systems, we need both conductors and insulators to make the current go where we want. Let's take a look at the spark block wire. On the top, you'll see two gold-plated studs. Those studs are the conductors that create a path for current to flow from one side to the other. There's also a third stud in the middle. That one's made from the same material as the rest of the block, a plastic material called ABS. ABS doesn't allow current to flow, which makes it an insulator. These two materials work together to make the wire. The studs are connected together, allowing current to flow from one side to the other. The ABS on the outside is the insulator that keeps the current inside, directing it exactly where we want it to go. When it comes to electrons, they generally don't like to be together in a crowd. They naturally want to flow to a place with fewer electrons. When we charge a battery, we're taking electrons from the positive side and forcing them together on the negative side using some fancy chemistry. This creates a difference in charge where one side has most of the electrons and the other side has very few. This difference is measured in a unit called volts. The battery in your SparkBlocks kit is a 3.7 volt battery. We'll discuss more about that in a later video. We're now going to build a way to test if something is a conductor or an insulator. To do this, we'll need the SparkBlock battery, the 1x2 wire, and a dual LED and resistor block. It's got a symbol that looks like this on the side. We'll start by lining the conductors up for the LED block and the battery block. Then we'll attach them together using the 1x2 wire. We can now use these two gold conductive studs to test if a material can conduct electricity. Let's start with the metal paperclip. If you lay the paperclip across the two terminals, the LED should light up. When the LED turns on, it tells us that we've created a pathway from one side of the battery to the other that allows the electrons to flow. Because the electricity can flow through it, the paperclip is made from a material that's a conductor. Next, let's try one of those more traditional plastic bricks. You can either lay it on its side or attach it to the top. Did your LED light up? Mine didn't. That tells us the material the brick is made from is not allowing electricity to flow through it. Unlike the paperclip, it's not a conductor, but instead must be an insulator. Let's take a look at this list of other things. Make a prediction about each item, describing it as either a conductor or an insulator. When you're finished, go ahead and unpause the video to keep going. Now that you've made your predictions, use your conductivity tester that you built and classify each item as either a conductor or an insulator. Great work, everyone! Today we learned some of the basic concepts of electricity and current. We developed an understanding of conductors and insulators, and we built a device to test materials and classify them as conductors or insulators. An electron may be tiny, but the world of electricity is huge. Today, you learn the foundational steps that engineers need to understand when working with and building electronic circuits. It won't be long before you're building them too. Ready for another challenge? Based on what you've learned, what makes something a good conductor? Do you think Play-Doh would be a conductor or an insulator? Use evidence from this lesson to help explain why. Next, Test your prediction using the conductivity tester that you just built.